All right, let's take a look at this homework here. Let's start with number one. A 0.25 kilogram arrow with a velocity of 12 meters per second to the west strikes and pierces the center of, should that be N? A. Of a 6.8 kilogram target. What is the final velocity of its combined mass? Right, and so we have an M1, we have a V1, right? We have an M2, and we are being asked for the final velocity. So, we're finding the velocity of a combined mass in an inelastic collision, right? And so we know that we have this conservation idea. Sorry. Uh, V2 final. So we have this conservation idea where momentum is conserved, okay? But especially if we're trying to find an inelastic collision, where the two objects essentially become one object after the collision, they stick together and they move as one. Remember, we can know that this final velocity for both mass 1 and mass 2 are going to be the same value. So that means that we can factor this out of this part of the equation, and we can get a version of the equation that's a lot easier to solve for that final velocity. You guys remember this from yesterday? So let's solve this equation. So divide both sides by, why do I always do that? It's not I, it's 1. And then M1 plus M2. That'll cancel. And so the equation that I'm going to plug and chug is going to be two V2 initial by M1 plus M2. So it's my M1 plus my V1 plus M2 that's V2. Oh yeah, it's gonna be 0 because it's a target. It's not moving. And then I'm gonna divide everything by the sum of the two masses. Was it 6.8 kilograms? And my final answer here is going to be kind of off the screen there. All right, all right. Inelastic collision. Part B, what is the decrease in kinetic energy during the collision? All right, so this is going to be the part that's a little bit newer when it comes to this particular homework. Are you good?
Yeah.
It's spastastic over there. All right, so what we need to remind ourselves of is that we can calculate kinetic energy here. Remember, it's 1/2 mv squared. And we can do a lot of work with kinetic energy and momentum because the equations are so similar, right? They both depend on mass and velocity. Now, they're not the same thing because obviously that is not the equation for momentum. So, what we're going to do here is we're going to start by calculating the total kinetic energy before the collision. So, kinetic energy initial It's going to be 1/2 0.25 grams multiplied by 12 meters per second. And I'm going to square that. That's going to end up being 18 joules, right? 18 joules. Cool beans. So that's the initial velocity. Now I'm going to calculate the final velocity. So I'm going to need to... Wait, did I say final velocity? I meant final kinetic energy. I'm going to need to understand that this is an inelastic collision, so the masses have combined, right? And so this is actually going to be both masses summed together. Multiplied by the final velocity that I calculated up here. That's going to be the final velocity of both of them. And then I'm going to square that. This bad boy is going to end up being 0.65 joules. So the change in kinetic energy is going to be whatever the initial kinetic energy was minus the final kinetic energy. So that ends up being 18 minus 0.65. And so it's going to be, what was that, 17.35, but I'm doing 2 sig figs, so I'm going to round that down to 17 joules. Okay? So the decrease is 17 joules. Now, the way I've written this, to be consistent, I've written this change in kinetic energy, so I'm going to need to include the negative sign, right? It's a decrease, right? It's a decrease.